Okay, so we are going to look at problem 19 from section 15 homework, and it's about a certain function, f of x, y, and we want to decide whether each of the points below here is the location of a local maximum, a local minimum, a saddle point, or not a critical point. The first thing we should check to see is whether it's a critical point. Because if it's not a critical point, it's not going to be the location of a local maximum or minimum or a saddle point. So we first check to see if it's a critical point, and for that we want to take the first derivative of f with respect to x and of f with respect to y and see whether there's zero at these points. So I took the derivative with respect to x. I'm going to get a 2xy here minus a y squared plus a 3y. And I want to check to see if that's zero at each of the points. And then we want to take the derivative with respect to y, where we get a 2xy, an x squared, a minus 2xy, and a plus 3x. And we want to see if that's zero at each of the points as well. So we go through each of the points. We start with 0, 0. Since x and y are both 0, we easily see that these are both going to be 0. Both of these equations will hold. And so we can check off A here. This is definitely going to be a critical point. Now we look to 0, 3. Here x is 0, and so this one's 0. This holds. But x is 0 here. We have to check. We have a minus 9 when y is 3 and a plus 9. So this is 0 as well. And so we get then that B is definitely a critical point. Turning to C now, where we have 1 for x and minus 1 for y. This will be a minus 2, minus 1, so that's a minus 3. And since y is negative 1, this is a minus 3 as well, and so this is going to be minus 6. So this is not 0. So this is not 0, which means we're not going to have that both of them are 0, and so this C choice is not a critical point. Now we turn to minus 1, 1. Again, this is minus 2, minus 1, so this is minus 3. But now, since y is 1, this is plus 3, and this will be 0. Coming over to f sub y, we see we have 1 here, plus 2. So this will be 3, and then since x is negative 1, that's minus 3, and this will be 0 as well. So both of these equations hold, and we have that D is in fact a critical point. Finally, we check the minus 3, 0, and we're going to have, since y is 0, that this is 0. And since y is 0, we don't have to worry about this term here, but we'll have minus 9 here, plus 9 here, and a minus 9 here. So that'll give us 0, and so this choice of E will be a critical point. So 1 minus 1 is the only choice that was not a critical point, and we need to check the other points to see if they are the locations of a local max, a local min, or a saddle point. So to do that, we need to use our function d of xy, and d of xy, to remind you, here, let me write this up here, this is f sub x, f sub y, and we're subtracting f sub xy squared. So we need to take the derivative of f sub x with respect to x, and that'll give us just a 2y here, and that's where this 2y is coming from. We take the derivative here with respect to y, and here we're going to get a minus 2x, and that's where this minus 2x is coming from. We also need to take the derivative of this with respect to y, and that's going to give us a 2x minus 2y and a plus 3. So we're getting that, and then again we want to square it, so we have this squared. And now we just want to plug this the points into d of xy to see what happens, and we plug them into plug in 0, 0 or 0, 3 or minus 3, 0. We see that x or y is 0, and so this part's going to be 0. So we're going to get that for each of these 3 points, this part is 0, and we're going to subtract. We need to make sure this isn't 0, but it's not. When I plug in 0, 0, I'm going to get just 3 here squared, and that's going to make this a minus 9. When I plug in 0, 3, this will be 0, but we'll have a minus 6 plus 3, which will make this minus 3 squared. So this will also be minus 9. And the same thing happens at minus 3, 0. This will be minus 6, and this will be 0, and this will be 3, so we'll have minus 3 squared, so we'll have minus 9 again. So D is negative for each of these, and whenever D is negative, that means it's a location of a saddle point, provided they're critical points, which we have already checked. Finally, we check minus 1, 1, and we check minus 1, 1, so that's our choice for D here, and we see that this is 2, this is 2, okay, and then we're subtracting, so we have minus 1 here, so this will be minus 2, this will be minus 2, this is minus 4 plus 3, so this becomes a minus 1 squared, or just 1. So we're going to end up with 4 minus 1, which is 3, and so D is going to be positive at minus 1, 1, and so that means the location of a local minimum or a local maximum, and we determine which it is by looking at the value of f sub x, x, or f sub y, y at the point we're interested in. And this is going to be 2, as we discussed earlier, and since this is positive, it's a location of a local minimum, because it's going to be concaved up in the direction of x. So we have a local minimum there, and we've determined what happens with each of the points, and so that finishes this problem.